We're recording. So this week we're looking at a glacier in Greenland.
Exciting stuff.
hmm The Helheim Glacier. NASA has been observing it since 2001.
So in my astronomy class today, we went into the observatory and watched a documentary on uh all of the Apollo missions
Yeah.
with trying to get to the moon and like NASA doing it and all the people that went into all of it and stuff, and it just like watching the videos of it, these people that work in NASA are just so smart. They're like beyond. Like, I don't know, they're just so smart, and like their brains just work in a special way. I don't know what it is.
No, for real. Yeah.
It's really
They're,
cool. And like the stuff that they're able to accomplish, like not just with space stuff, but like with this like glacier stuff and watching all of it, it's really cool.
for real. And I love that they don't just focus on space.
Yeah,
They're
yeah,
looking at different phenomena around the world too, which is really cool.
yeah.
Okay. So I think I'll just share my Google Earth with you,
Okay, that'd be great.
and that might work.
Great.
Okay. And also the oh, it's not working. There we go. Okay. So it says using historical satellite imagery, we can measure the changes in glaciers over time. As a group together using the images provided by NASA below, observe how much retreat has happened to the Helheim Glacier in Greenland since 2001. Use some of the features on the edges of the glacial valley to note the locations of the glacier margin in 2001, 2003, and 2005. So we have a place marker, which is that yellow pin,
Mm-hmm.
and we for the location of this glacier. So we use that. Um, and use Google Earth to estimate how much retreat has occurred over the past 14 years. And then in a group discuss possible reasons to explain this amount of retreat in such a short period of time. And on the one page it has a picture of June 2005, which is, can you see my mouse?
Yeah.
Okay, so in the picture it's very similar, maybe just like a little bit further up, maybe like a tad further up. So it hasn't moved a lot since 2005, but I'm guessing between 2001 and 2005 it moved a lot.
Yeah.
That's probably what we'll see.
Yeah. Yeah, it doesn't look like it shifted a ton because you can see that little runoff on the side to like the north of it, if that makes sense.
Up there?
Um, no, like near the edge of like where the equilibrium line and like the waist zone meet. There's like if you go like directly above it, yeah, you can see like the little like runoff. It's not like hardly any further like away from that line in relation.
Like right there?
Yeah. Yeah.
That little, that's probably way bigger than we think, but it
Yeah.
looks really small right now.
Like I was thinking about like the really dark divot to the right that's pretty big. Um it looks like
This
it
is
has
so cool.
That is cool.
Yeah, because I feel like that's huge.
Mm-hmm. Yeah. Yeah. It really hasn't, like, when you look at that point and then, like I think it's called equilibrium line.
What is this? Is this water? Like dirty water? I think it's dirty water. Is that like a cirque once upon a time?
A what?
A cirque?
Mm,
Like once upon a time, maybe?
oh. Maybe.
They don't have like
Honestly, that makes sense with all the melting that's going on there.
I was just like, they don't have anything over there, but no, that's like the glacier. This is so white. This is the glacier. Okay, anyways, we
Okay.
oops. There we go.
So how do you check out like what it looked like at different times?
Okay, so what you do is you go up here and you can look for 2001. There we go. Okay, 2001.
Oh.
Whoa, it's moving. Do you see that?
Yeah.
That's so weird.
Why is that moving?
Is it the water? Whoa. I think it's water. Anyways, you can see like a lot of snow. The glacier is like all the way to the end. Like the accumulation zone is down here.
Yeah.
Am I getting the anatomy right? Oh, it's Elisha.
Oh, did she not understand that we were getting on your profile thing?
I'll forward it again. Actually, I'll just.
Oh.
It's funny. She's like, where the heck are they? Like, it says she's there. It's not loading. Elisha, can you hear us? Elisha. Oh wait, I just heard something coming from you. We can't see you. Can you see her, Emily?
No, I can't see her.
Okay, Elisha, we can't see you, and we just randomly heard a sound come from you though. So okay, just trying again. Oh, you know, I just realized we could do.
What?
Actually, I'll explain it when Elisha gets on. But I figured out an easy way to measure it. We can just use a path.
Okay. So are we able to put like a pin, because this is 2001.
Yeah, I'm wondering if we can put another placemarker. Hey, Alicia,
Hi.
we can see and stuff now.
Yay.
Okay, so we have it set up. What we're doing is we're looking at the glacial retreat of the Helheim Glacier in Greenland since 2001.
Mhm.
So we used this clock thing, which takes you back in time because NASA's been watching it. So there's all these pictures. And if I take off the clock, like this is what it looks like now. You can see how far it's retreated and everything.
Mhm.
So one of the things that we have to do is, okay, why does it say past 14 years?
So we're looking specifically, I think most of the retreat probably happened between 2001 and 2005, and that's why he wants us to look at 2001, 2003, and 2005. But then I think that he wants us to get an idea of how much it's really retreated since 2001 to now. Oh, wait. How many years is it? 14?
2005. Yeah, it says 14 years.
Oh.
And I was like confused because I was like, from 2001 to now, it's 18.
That's right, yeah.
But from 2005. Okay. Because I was looking at it and I was like, oh, he wants it from 2001. But no.
Oh, yeah, we can do this. So we can call this 2001.
Oh.
Helheim Glacier. Because what I'm doing is I'm just taking like screenshots of these and posting them in the Word document, so he can just like see that we're doing it. Because it's not really specific on what we're supposed to put on there, except ideas of like why the glacier retreated so much in such a short amount of time.
Yeah.
Okay, so where would you say the accumulation zone is? Like here?
Yeah, I think where that color change happens. Into that like gravelly gray.
Yeah, because that's when I think it's really blending into the water there. I'll stick it about there. Okay. And then 2003.
Yay.
Oh, we can see like it's definitely retreated a bit more. Like
It's like the edges are like where the colors are like where it starts to turn into mush,
like right here?
Down a little bit further right. But the colors look like the stuff that you see like when it's like wet snow, like really wet snow, like slush. Does it look like that? So a bit like slushies.
Wait, okay, guide me. Tell me to go like left or right or up or down.
Like there's that one channel right up there where it's a little bit more blue. That looks a little bit more like where it's kind of like it's like ice that's like very soft that's sitting on water right now, and then at the edge of like the entrance.
Oh, like right here.
No, further right, towards the pin of 2001. Further out. 2001.
Wait.
Like where the blue of the water starts to meet at the entrance of that channel.
You mean like down here?
Yeah, it looks very similar as like up and that.
Okay. Well, it is supposed to be moving this way though.
Yeah.
So okay.
I see what you mean. I'm trying to figure out like what This stuff is. Because if you look at it, like, this is creepy-ish. Emily and I were looking at us like, why is this moving? I think it's just water.
Is it? At first I thought it was a cloud. I'm looking at the thing right now, too.
Oh, it might be clouds.
I thought it was clouds. But then, like, it's also moving on mine, too.
Well, isn't the
What if it's like surface melt? Like, you know, like there's a lake on the glacier.
Oh, what are they called? I put it in my narrative. The Playas Lakes. Is that what it is? Are they the Playas? The Playas Lakes?
I don't know, cause like I don't know if you can actually really call it a lake or anything, because like you know where the part where it meets into like that ocean.
Yeah, it does go into the water there.
So.
Okay.
Lake.
Isn't the accumulation zone to the left where all the white is?
Like, you mean like over here?
Yeah.
I just want to like.
Could be debris.
Because I thought the white part was like where all the like snow and ice adds up and stuff.
Oh, okay.
I thought that was the accumulation zone.
So as I move towards 2016, we could see that it is moving in here. I don't know what the heck this is.
Do you think that's like the ice becoming like transparent, and so it's like, because you know how when like ice starts to melt, it like becomes kind of transparent, and you can like see like you can see the ground under it. So it makes.
Oh, this has helped. Yeah, I think you're right. I think it's ice. That would make to me that would make a lot of sense.
What if there's a body of water under the ice? That's why it's moving.
That could, yeah. Oh, that could totally be it too. Yeah. Okay. So, okay, this is the most recent, and this was where we started in like 2001, and this is where it is in 2016. I'm just gonna stick a thing here.
Mm-hmm.
Oh. Okay, so let's look back at 2001 again. I guess that guy could be moved up. Directions to here.
What if that's actually also like showing the active areas of it melting like down, and like how it's receding, the ice part is receding?
Yeah, that could totally be it too. So 2003. I feel like it kind of did freeze over a bit more. When you zoom out, you can kind of see that this has melted quite a bit. Mm-hmm. Like it is super choppy, but it's so trippy. It weirds me out. They just don't have like the best photos.
Like once you get closer, the pixels really bother me.
Have we labeled 2003 yet?
No.
Not yet.
Would you say this would be 2005 because it's kind of showing like I would say that's receded to that point, honestly, just because you can more clearly see the water.
Yeah.
'Cause this color here, that's
It's kind of weird how it's like in lines.
yeah, I think it's just like the photo quality.
Oh.
So,
Yeah. Yeah. If it was melting like that, we'd be like, okay, what's going on here?
it's not entirely impossible, but like to have something that's like perfectly rectangular like that, it is probably something that has to do with the program. But I mean, if it's something that melted, I wouldn't be surprised if it kind of had something that looks like fingers.
Oh my gosh. I was in Yellowstone last weekend and it's called the Sheep Eater cliffs or something like that.
Oh.
And I don't know if y'all have seen them, but
Sorry. Google Drive Google Earth just closed on. I'll just open it back up again.
This is very rude. But they're so cool. They're like basalt lava flows that form like columns.
Ooh.
It's so cool. They're like these giant cliffs with like these like columns and I don't know.
That's
We
really
climbed
cool.
them. They were super fun.
Are you talking about the ones that look like the ones in like Iceland where like or something that's like in northern some northern place where they call it like the giant split or something like that, like where there's kind of a certain hexagonal shape? Is that what you're talking about, or?
It's like these cliffs up near Mammoth in Yellowstone.
I think I know what you're talking about. Like,
It is in the northern part of Yellowstone.
yeah.
They're really cool. I feel like you probably do know what I'm talking about because if you see them, like, you don't forget them. I've never seen anything like it.
Yeah. Okay. I think. I should check in the
Huh?
It's.
Okay.
Are you talking about this one?
Yeah, they look like that, but it's not by the water. The one that we saw, it wasn't by the water, but those are it. Those are the basalt lava columns that I'm talking about.
Right, because they actually have a lot of these out like in the northern part of Europe and I think some areas in the UK as well. So these are very common.
Yeah. There are some like that are in Yellowstone. Aren't they so cool?
Yeah, they kind of are. I was talking about like going to Iceland with my boyfriend because like they actually have a lot of these structures out there as well. So like,
That's cool.
This is kind of pretty cool. I mean,
Whoa.
Yeah.
Okay. We
But
are.
then like they only appear vertical most of the time, right? They don't like go parallel against the ground or anything. Like they don't grow like this, do they? Like parallel. They don't do that.
Okay. I got up and running again.
Oh, sweet.
So I am going to try to get out of this. Okay.
I just gotta redo those. They ended up not saving because it crashed.
Okay.
My sister's in Florida, and she just sent me a thing, and it's like in the 90s, and then you know how they do the weather where it says like feels like, and it's the like, you know, I don't know, it tells you what it's actually supposed to feel like, and it's supposed to feel like 180.
What? Oh.
That's so hot, and it's really humid there too, so it's like, ugh.
Okay, 2005. Where did you guys feel like the accumulation zone was?
Oh,
This is in December, so it would be like the dead of winter in Greenland. Whereas, yeah, okay, this is all taken in December.
What if you tried doing like a little bit of summer? Like summer's probably the worst.
All right, well, we can't view summer. We can only view when the photos are taken.
Oh, okay.
Unfortunately, otherwise it'd be like, it would definitely, I feel like it definitely would be easier to see the glacial retreat over time if it was the pictures are taken in the summer. Maybe it didn't move that much within the 2 years and just more. Because I would say it's still really close.
It seems to be like it seems like a little bit of a consistent rate if you look at the 3 time periods, but given 2001 to 2005, that's isn't 2013 old?
say that one more time.
Is the one at the back the one for 2005, or is the one with the pin at the back for 2005 or 2003?
The one that's like all the way back?
Yeah, all the way back, like further up on the screen.
Aubrey, did that one come with that pinpoint?
This thing?
Yeah.
Yeah, it was just a place mark for be like, here, this is the glacier.
Oh, okay.
Yeah. That's the link that he gave us in the on the assignment page. It's cool. Okay, my favorite part is to watch this part here, though, because I feel like you can see it a lot more clearly. But then you can see how this is breaking up and becoming more part of the ocean here in 2015. In 2016, it's like moved. I'd say up here would be like the very end of it.
I wonder if any like chunks of ice have like broken off and become icebergs.
I would believe it. And then like this is the end. Like how abrupt that is. And like this is legit. Like that's how abrupt it is.
Nature.
Darn nature.
That's pretty neat.
29. Whoops. 2019. Okay.
The distance from 2005 to 2019 is about the same as 2005 to 2001.
That's true, yeah. It totally, yeah. 2001 to 2005, I definitely think that's when it was moving the most, for sure.
Yeah.
Oh yeah. And are we going to look for distance or like elevation profile right now?
Just the distance. So then I can pull out this
Little
handy
measuring
dandy ruler.
Yep.
About oh. Because this is the accumulation zone is huge. And like right now is the best quality picture.
Mm-hmm. Despite how pixelated it is.
Mm-hmm. Okay. What was that? That was 8.32. So I'm gonna copy that and then put it on our.
How far was it?
We measured 8.32 kilometers. Do one of you want to Google fact check that?
Oh, we're supposed to do it from 2019 to 2005.
Oh.
I'm pretty sure. I mean, for me, it makes sense to do it from 2001, but
This is 14 years.
he said the past 14 years.
Okay. Then.
And I'll Google check it.
Okay.
Yeah?
I have a Chromebook, so my Google just started talking to me.
Yay.
It was like, what can I do for you?
Do you actually like using a Chromebook?
I have liked it until this class when I've needed to use Google Earth and like I can't download the software.
Because the original purpose for having a Chromebook is actually to utilize it with the Google Classroom thing that they designed. And so I was actually trying to get my school to use it, and I think after my batch tried to like convince the school to actually allow us to use Chromebooks, the teachers took our idea and they started giving like the students like more support and whatnot in terms of tech and whatnot. It's so archaic. Our school's so archaic.
Yeah.
Yeah, that's what happened. It's pretty sad that my batch didn't get to have it, but like coming out to like uni, I've discovered that it's only pretty good in high school, but after that, it's not as good to use.
Yeah, it's been like, so I didn't come into college with a Chromebook. My Asus that I had actually, it like the hard drive crashed, and I didn't have the time or the money to like get the hard drive fixed because apparently it was supposed to be like super expensive and I didn't know how to do it myself. And so I just bought like a cheap little Chromebook, and it's lasted me longer than my Asus did. It's been pretty fast, but like I can't get the software that I need for like my science classes. Like using Excel has been an issue because like spreadsheets just isn't the same, and using Google Earth is a struggle. But using it for like classes that require like a lot of reading and writing papers and stuff, it's been fine.
Right.
Yeah.
I mean, because like most of the stuff, like the good thing about Google Chrome is that we give you like cloud storage, a large amount of cloud storage. And so you can actually pretty much do everything online, right? there's drawbacks. Parts of like the system does always second loss.
Yeah.
Okay, so I measured 4.67 kilometers from 2005 to 2019.
How would it retreat?
I'm reading about it.
What?
I'm kind of having a hard time finding it. Oh, what'd you get?
4 point. Oh. Oh, you know what? I don't think we're far off. I got 4.67 or something like that. But it says on Wikipedia, Helheim Glacier accelerated from 8 kilometers per year. Oh, I think we're way off.
Yeah, that's kind of what it's looking like.
We're way off.
Its speed increased from 8 to 11 kilometers per year between 2001 to 2003.
So
I'm looking up like this one NASA thing that has a page on just that thing. So is this from like 2000 to 2005? It says that Helheim quickly increased the rate at which it dumped ice to the sea, while also rapidly retreating inland, a behavior also seen in other glaciers around Greenland. Since then, the ice loss has slowed down and glaciers has partially technically advanced by about 2 miles of the more than 4 miles that it had initially retreated. Do you think like part of it is because like it's at like this feeding part into the ocean that everything else, like say if there's like water or something that melted, the water kind of like, you know, when water runs on ice, it kind of like melts the ice a little bit, and then further like it melted a lot quicker, and so once that happens, it probably breaks the ice open, and that's why it like melted so rapidly, or like decreased in size.
I don't know. I'm just kind of confused because what I found it said that it was like 7.5 kilometers between 2001 and 2005. So like, but it's not telling me what it was for 2005 to like 2019.
yeah. Oh. Okay. Well, I found something. I'll just take a picture of it and send it to you guys.
It says that at the Calvary Front retreated 2.5 miles between 1998 and 2013.
Look at the picture I just sent you guys. Oh, I found an even better picture. That just has everything. Okay, the pictures on Google Earth seriously suck.
Yeah.
Because it's so pixelated. It's so, like, once you get really close.
And
okay,
let me try and find this picture. Glacier. Here we go. Okay. Like, seriously, this would be so much easier. Wait, maybe we're not that far off from like the specific spot we're looking at, because I'm looking at this image here. I'm gonna look on Google Chrome really quick to see if you can do the same thing.
Oh, wow. Yeah, that one with all the lines is really good.
Yeah, I know, right? So probably would have been helpful if we just looked at that.
Yeah.
It really jumped from 2001 to 2003. So like we weren't off with that.
What happened in this? Okay.
Okay, I think that's what we need to look at is the okay, is let's get rid of this. What we need to be, oops, no. There we go. What we need to be looking at is this. This is the terminus. Right here. And so this is actually 2019. This is what we're supposed to be looking at. So this should be like marked here. Okay. So then I don't think we're off with 2001 though. Like I feel like we're probably pretty close, but then say that again. I couldn't hear you.
Like within those 3 to 5 years of 2000. I'm just trying to figure out what came after the death.
Okay, so if we hit this again. Do we just need to like zoom, keep zooming in and out? That doesn't help. By looking at this picture that I had found,
what? Okay, so like at some point in those few years there was, it's like, you know how like from the Gulf Stream, like along the east coast, the warm water is brought up to the north part? What if there was like one of those particular years that was really hot, and then the water that was brought up warmed up the whole area so it like tasted like.
So basically saying that the water, oh my heck, this would have been really helpful. Just done. On the document that he gives us, there's a picture of the 2005. The terminus. So sorry, Elisha, you're saying pretty much that water is the main cause?
I'm not saying it's the main cause, but it's possible because I can't think of any other thing. Because like, if there was like some other place in the world where there's like major volcanic eruption, how like there would be ash covering and whatnot. But then if that happens, if the ash went over to the Greenland area, it would cover them. That would actually allow it to freeze a little bit more instead of melt. But
I just remembered that I literally just studied this in one of my other classes.
Yeah.
This past week, right? What you were saying just reminded me. I watched a video on this glacier, but one of the reasons definitely is water.
Yeah.
The sea levels are rising. The sea level is rising, and so the glacier is losing ice. But also, you're right. Like with like ash and different like pollutants, it falls onto the snow, and it's dark in color, so it attracts more light and heat, so it melts more.
Oh, look at that one. I just thought of like the ash being still airborne.
Mm-hmm.
Yeah.
But I think, yeah, like the warming and.
But like, I'm just talking about general, like not just like I'm just talking about general water current, because I know that